In our laboratory, we use X-ray vision to look at Australia's past. Let me just give you an analogy. Imagine you're 2,000 years into the future and you find this DVD. Now, never having seen one of these before, you're not quite sure what to make of it. So you can observe its shape and color and size. And of course, 2,000 years in the future, there are not DVD readers. So you begin to wonder, who made it? Why did they make it? And what sort of cultural information is encapsulated within it, since it's out of context now? In that same way, in my laboratory, we look at Aboriginal artifacts such as these and ask some very similar questions about where they were made, how they were made, what communities they came from, and what their cultural meaning is. For we do know that objects treated with pigments such as these are more than just paintings, and in fact, a lot of the cultural information comes from the pigment itself. We do know that in certain important ochre sites, Aboriginal people would travel for hundreds of miles at certain times of the year to go access the ochre mine, as well as make its cultural connection to the landscape. But unfortunately, many of these connections and routes have now been lost, and all that we are left with are the objects themselves. So we have to analyze them in a different way to retell these stories. One of the ways that we tell these stories and look into it is through X-rays, by using a portable X-ray spectrometer such as this one. This works very well for cultural heritage analysis because it's portable, handheld, and can be used in the museum and the field. But most importantly, it's non-destructive to the objects that we analyze. This emits X-rays, which excite the atoms in the object, causing them to emit X-rays, which we can then record and interpret on a spectrum such as this one. Each X-ray is characteristic and allows us to identify the chemicals present or elements present in each object. In that way, it's similar to this torch here in that we can shine a light on the object. However, we get much more information back than just the reflected light. By interpretation of the chemical results through statistics, we can then recreate some of these exchange routes. We can then take it a step further by analyzing the same objects on the Australian Synchrotron on the X-ray beamline in Melbourne, where this is the first experiment of this type of taking Aboriginal Australian objects being analyzed at a synchrotron. The advantage of this is that we have X-ray beams that are thousands of times brighter, yet hundreds of times smaller than a human hair. And in this way, we can analyze a very small area, just the size of a matchbook, and come up with understanding the chemical technologies and begin to recreate some of these exchange routes. Some of the images that we get back, instead of being a snapshot like the portable XRF, actually gives us a high-definition image, almost like a high-definition digital camera, for point-by-point analysis. So each one of these points is actually a spectrum. And we can create color maps of individual elements to understand the object even better. From here, we can see the high iron areas or ochre, the pigment that was traded across Australia, and we can begin to identify some of the sources of this ochre. The white material is kaolinite, a type of white clay, and the black areas are likely made up of charcoal from burned bone. So not only can we understand and piece together some of these ancient technologies and recreate some of these ancient exchange routes, we can now peer into Australia's past and recreate some of these cultural connections which have now been lost to time. In this way, we can use analytical chemistry to better understand our humanity.